All right, ladies and gentlemen, we're looking at 7.3. We're back to, remember last section was all about similar triangles? We're going to use similar triangles with right triangles to figure this out. So our three new vocabs that you should put on your vocab sheet are theorem 7.5, which if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle. So let's draw a picture of that. We've got a right triangle. So if the altitude is drawn to the hypotenuse, so that's the altitude. Altitudes have to be at 90 degrees. All three triangles are similar to each other. So the one in black is similar to the one in blue, which is similar to the one in green. So if we're going to label these, so we can say A, B, C, and D. So if we say triangle ABC is similar to triangle BDC, that is also similar to triangle ADB. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric means of the two segments. Okay? So, if I'm looking again, I've got my right triangle, and I've got my altitude. These two numbers, I'll call them A and B, give you the altitude. The square root of A times B, and I'm going to label the altitude D, gives you D. Remember the geometric means? Two things multiplied together taken by the square root? That's where this comes from. All right. It is. ABC is similar to BDC, which is similar to ADB. This is D, the altitude, and the square root of AB equals D. In a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of a triangle is the geometric means of the length of the hypotenuse, and the segment of the hypotenuse that is the adjacent leg. That's a lot of stuff. Let's break this down. I'm going to move this out of my way so I can draw a nice picture. Okay. So let's draw this as it says it. In a right triangle, so I've got a right triangle. The altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. We'll label them A and B. The length of each leg of the triangle is a geometric means of the length. This is where I get confused. The length of each leg of the triangle. So here is each leg. The length of each leg of the triangle is a geometric mean of the length of the hypotenuse. And the segments of the hypotenuse is adjacent to the leg. The length of each leg of the triangle is a geometric mean of the length of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. We'll look at examples for this one because I think, one, I'm confused. Two, I don't think us writing it down in letters is necessarily going to help, but I am going to look at the book and see if there's a nice picture for this one that might help us out. All right, if we look at 7.7 on page 532, the picture they drew looks like this, except they labeled it a little different. Let's label it like they labeled it and see if that makes a difference for us. We've got, this is A, D, B, and C. B, C. Okay, they said A over B, so A over B, the whole length of the hypotenuse, over C over B, so this leg right there, equals the leg, C over B, over D to B, that segment. Okay? So, this means, well, CB and CB gives me CB squared. So if I labeled these X, Y, and Z, let's go with this for a second. Let's label A to B as X. We'll label C to B as Y. And D to B as Z. So what this is saying, AB is X, D to B is Z. Z is D to B, the length of D to B. That equals C to B, which is Y. Okay? So the length of the hypotenuse times half the hypotenuse equals, if we multiply them together and take the square root, it equals the leg. So let's try and see if we can figure out the other leg using this information. So we're going to take AB again, because that's the hypotenuse. And we're going to put it over, see how they put it over CB? Let's try the other side. CA. We okay so far? No. So we found the length of this leg right here, right? We found the length of this leg right here. Okay? I'm going to try now to find the length of this leg. This leg right here. Okay, so I'm taking, this is what it says. It says take the hypotenuse times my leg equals the leg, CA, times half of my hypotenuse, this half of the hypotenuse. So that gives me CA is equal to the square root of AB times AD. Okay, that was really confusing. We better try some of those with actual numbers to make it work for us, right? Because that was a lot. And I don't know if you still don't get it, and I totally understand that you don't get it. That's okay. Let's go to some of them where we have, so we're going to go to example 2, 3, and 4 and try some of these with numbers. Again, there's lots of proofs on here. My deal with the proofs is if you want extra credit, you can do them. I think more use of our time, since I'm not going to test you on the proofs, is to go to the problems that are ones like I would test you on. Okay. Okay. So we're going to look at A. And A gives us this at the top. X over 12 equals,
excuse this interruption.
question mark over 8.
Seniors, at this time, you are to report to the PAC Center. Teachers, if you have just seniors in your class, you are to escort those students down to be with them. Once again, all seniors report to the PAC Center. Teachers, go with your classes. Thank you.
Okay. It kind of wants us to set up a proportion here. I'm going to show you 2 ways to do this problem. Okay. The first way is if we've got X over 12, it would be 8 is like, see how X is a leg and 12 is the shorter leg? We would have X over 12 equals 12 over 8. And then we cross multiply. But the point of this is that this is the geometric means. So that should mean that 12, so geometric means, remember, is the altitude equals the 2 other numbers multiplied together squared. So if the altitude here is 12, this should equal the square root of x times 8. How do I get rid of that square root first? How do I get rid of a square root, guys, in general? The opposite of a square root is to square it. There we go. we square it. So we get 144 equals 8x, and then we divide both sides by 8. 144 divided by 8 gives me 18. Do you want to see the other way to do it where you just cross multiply? You're going to get the same thing. X times 8 is 8x. 12 times 12 is 144. See how it ends up the same thing? This is just a shortcut. You don't have to use it. Okay, let's do B. We might have to do all of these guys because I feel like these are a little complicated. Okay. So now the ratio it gives me for this one is 15 over x equals, I'm not sure why we're talking while I'm talking. It might be because you're trying to understand it. But remember, one, this is recording. And it's annoying for somebody who's trying to listen to this to hear your voice. Two, some people can't understand what I'm saying or listen because you're talking. Stop. Okay, we've got 15 over x equals x over what? So remember, they're similar triangles. Okay, so we've got 15 over x. This would be 5, right? Okay. Also, remember, you would get, to get x, you would just do the square root of 5 times 15. They will give you the same thing. I just like to skip right to the point and do the square root of 5 times 15. You can cross multiply, you'll get the same answer. It is approximately, and it doesn't say put it in radical form, so I'm just going to put the decimal, 8.7. How are you feeling about this, guys? So-so? Do we want to try C, or do we want to move on to a different one? Try C. Okay. Give me 1 second. Let me put these on a different page. I did move it a little bit, but this is C. And we're given 9 over x equals x over what? Okay, if we have 9 over x, and then x over, what's the whole length? 20. And then for this one, why don't I just do the cross multiply, and I won't skip to my crazy part. 9 times 20 gives us 180. 180 equals x squared. To undo x squared, remember it's the square root. So I take the square root of 180. Do you want to practice radical form? You might have to do it on the test or quiz. You're still okay? All right. 13.42 is approximately x. In radical form, I would take 180, and I would say, okay, what's the biggest perfect square that could possibly go in there? And find it till it goes through it. So I write 180 divided by 169 doesn't go in there evenly, and then I keep going until I found it. Okay. Let's do these next ones. All right. These say we're going to write a similarity statement for 3 similar triangles in a diagram. Okay. So the first thing we have to do is we have to find the missing thing, and then we can write the similarity statements or write the similarity statements and then find the same thing. I'm going to write the similarity statements first. Triangle QRP is similar to triangle, so I've done the big triangle,